These are the notes for section 5.7, inequalities involving two triangles. I will be able to apply the SAS inequality theorem, and I will be able to apply the SSS inequality theorem. So the names of these inequality theorems aren't too important. You have to understand the thinking behind it. The SAS inequality is commonly called the Hinge theorem. It says if two sides of one triangle are equal to two sides of another triangle, and the included angle in one triangle has a greater measure than the included angle in the other, then the third side of the first triangle is greater than the third side of the second triangle. A lot of words here for a theorem that really isn't all that hard to see. To kind of give you an idea, the best case scenario, which I'll go over in class with a visual, is just opening a door. The size of the door doesn't change, so you can kind of think of this side here as being the door, and maybe you could think of the one with two sides being the doorway. So the wider you open the door, the greater the distance is between the end of the door and the end of the place where the door goes. Again, easier to see in person. There's a lot of words here. But let's talk about a few things here. We haven't really talked about what an included angle is. An included angle is the angle that's between two specific sides. This time we have marked sides. So because we're between the side with one tick mark and the side with two tick marks, we're there on both triangles. We have an included angle that's greater. So all this says is since 110 is greater than 80, I'm getting those numbers 110 and 80, the included angle is greater. So since 110 is greater than 80, then segment RT is greater than segment VX. I think nearly all of you should be able to see that just from the visual. And like I said, we'll go over more examples in class where you can see it better firsthand. We also have the SSS inequality, or the converse of the Hinge theorem. This says if two sides of one triangle are congruent to two sides of another triangle, and the third side of one triangle is greater than the third side of the other, then the angle between the pair of congruent sides in the first triangle is greater than the included angle in the second triangle. So again, we're just working backwards this time. I have 8 and 7. And I have an included angle right here. So since 8 is greater than 7, then angle B, which is across from 8 centimeters, has to be greater than angle F, which is across from 7 centimeters. Again, a pretty simple concept, and I think all of you should be able to see that F's acute, and it looks like 8 could be a right angle. So the visual helps a lot with this as well. So what are some examples that we have? We're told MPR, so we have this side here and this common side, and we have NPR. Again, we have the 1 and the common. What's the relationship? Well, 13 is greater than 10. So 13 has to be greater than 10. NPR is greater than NPR. We're working backwards with number 2. We have these two sides in common, and they share a side. So 21 is greater than 19, so that means MR has to be greater than RP. Let's go on to number 3. We have two sides that are congruent, 24 and 30. So 50 is the bigger one. So 50, we always point to the smaller one. So the measure of angle C is less than the measure of angle Z. For number 4, we have two sides that are the same. And the bigger angle is 62. So that means HK is bigger than EG. So again, we point to the smaller side. EG is less than HK. The last thing that we do in this section is we're writing inequalities to describe the possible values of x. Well, let's take a look here. So I'm right in inequality. Here's my number with x in it. I see that it's across from 120. 120 is the bigger one. So I'm going to say 4x minus 10 has to be greater than 40, because 120 is bigger than 115. So I just solve this inequality. I add 10 to each side. 50, and then I divide by 4. X is going to be greater than 25 over 2. So for this one here, I see again I have my sides in common, so I can use the theorems that I just learned. 36 is bigger than 30. So that means 3x minus 3 is going to be less than 33 degrees. And I also know that I can't have a negative number for an angle. So this angle also has to be bigger than 0 degrees. So this is a compound inequality, which is how you'll start the year off in Algebra 2. You should have learned about these in Algebra 1 also. In order to solve for this, I just add 3 to each side. I get 3 is less than 3x, which is less than 36. And then I divide by 3. So I have 1 is less than x, which is less than 12. And that's it. I wrote an inequality to describe the possible values of x. That's what the directions said. Please come to class prepared with any questions you might have on this section.